All right, so really it's going to show us how to. Lydia, are you saying you want to share your screen? Arilla's going to share her screen first, and then I can look at anybody else's screen if you guys want me to. All right. So Aurelia went to her notebook. She signed in. Ah, click their name. Does yours look like this, Jessica?
Yeah.
Okay, try clicking that little arrow. Yeah, that's. Oh, Jessica, maybe yours doesn't like that because I added you late. Okay, I may need to add the class notes, homework, and keys. Jessica, that might be
I
yours.
see the name under the library thing.
You see your name, but you don't see sections, do you?
It says homework keys and class notes.
Yeah, exactly. So just click one of those, like you can click in any of those, and then you can just write me a note. That's all. I just want to make sure you guys can get to it. So like the notes, those are the notes we're going to work on today where Aurelia is right now. So like Aurelia, just type your name where it says name. So she's just going to click right there.
I clicked on class notes, but it didn't take me to that. It was just a blank page.
Yeah, the top one is a blank page, and then the one under it says should say notes and
Oh, okay.
momentum. Perfect.
I just had to refresh it.
Perfect. Good. And so on my end, it just shows me when you guys are now, by all means, if you rather be on paper, that's totally fine. But I'm gonna put a bunch of stuff in here for you guys so you guys can always see. Because you know it's kind of hard because it's like I can put all these worksheets on Schoology, but then it's like when you remember how like we got into like a couple units, it'd be like, all right, click this folder and click this folder and click this folder and click this folder, and then the worksheets in there. Well, now you can just go here and all the worksheets will be in one spot. You click one time and then you can just scroll through. Because what's going to happen is where it says untitled page and then it says notes momentum, I'm just going to tell you what the name of it is. They're all going to go there. And then um, there is a way, let me see if I see it on Aurelia's. Yeah. And it doesn't have to be perfect, guys. I'm not going to check this. This is just so you can see what I'm seeing. Okay. This is just so you can see what I'm seeing. And then if you want to print it out, you can. If you don't want to, you don't have to. I just want you guys to be able to have access to that. So I'm gonna go look and see who I've seen who has been in their notebook. I can see that Jordan's been in his. I can see that Jalen's been in his. I can also see, let's see, Kaylee's been in hers. And I can write her back. I would like to. And nobody can see what's in Kaylee's notebook except for me and Kaylee. And I can write to Jalen. All right. I just want you guys to be able to, anybody else having problem getting to their notebook, even if you say you don't want to use it, I want you to be able to get here because if I give you some keys and stuff, you can stop sharing earlier. Thank you. If I give you like a homework key or something like that, I want you to be able to find it. Okay. Anybody having problem getting to their notebook? Okay. All right, Bless. Did you click that link, Bless? Okay, and then did you sign in? Or really, can you tell us one more time what you sign in with? I'm gonna write this down so I can remember it myself.
Okay, so when you click on the link in Schoology, it should make like a weird little meanie face in the middle, and then you click the arrow, and then it's gonna take you to Microsoft, and it's gonna ask you to sign in. You put in your school email, which is your lunch number at Marietta schools.net, and then your password is your birthday, which should be whatever, whatever, whatever. And then you click sign in, and it should take you to welcome. And then under welcome, you should see collaboration space, content library, in your name. You click on your name, and then class notes, and then notes momentum.
Thank you. Okay. So if you are still having problems, we can, because we'll probably finish class a little bit early. Then I can do a couple of breakout rooms. Oh, fantastic. Bless you. Great. We can do a couple of breakout rooms, and I can try to get you in there just so you can have access, because I want to be able to give you guys all the worksheets and stuff. All right. So, all right. So let's jump into the notes. So this new unit, I'll keep recording. All right, so this new unit is called Momentum and Impulse. So if you're in your OneNote, so you have an option, you have OneNote, and then you have just a PDF that's in Schoology. It's the same thing though. But if you're in your OneNote, I'm just gonna share my screen one more time. Okay, and mine looks a little different because I'm not in the online version, but there is and I'll try to show you guys that when I come back to school. You can, some computers have this program and you can open it here, okay? So for instance, if I go to Bless, if I go to your class notes, I'm gonna open this PowerPoint on my computer so you guys can see it, but we're just gonna be filling in these notes right here. So for instance, like Bless can just click right here and just type, whatever you want to, okay? Or if you want to write on paper, that's absolutely fine, okay? But we're going to cover, let's try to get through 1, 2, maybe 3 pages, okay? Let's get through these first 3 pages. I don't think it'll be bad. If you have a calculator, you can use that. If you're in school, I will get someone to have calculators out for you guys on Thursday, okay? All right, so are we all set? We're gonna take a little bit of notes and then you guys can work on a little quiz for the day if you want, okay? All right, so I'm gonna share my screen again. I'm gonna first set this up. All right. Momentum and impulse. All right. Can you guys see that? Okay, somebody unmute and tell me because it'll be too hard for me to check the chat. You guys see a green screen? It says momentum and impulse.
Yeah.
Okay, thank you. All right, so momentum and impulse. So there's a little bit of math in this unit, but it's not super difficult. We got some more letters that we have to learn, okay? But it's kind of connected to, we just finished talking about forces. Remember, a force is just a push or pull. And then remember we did some stuff with net forces, like what's left over. We've talked about, when we talked about 1D motion, our velocity and acceleration and speed, all that stuff. So this is kind of just a small continuation of that, okay? Still talking about motion. So momentum and impulse. We're gonna talk about just momentum today and we'll talk about impulse another day. All right, so I have a quick video for you guys. I know it lags sometimes, so I'll put these links to these videos in Schoology as well. So let's make sure. You tell me if it's showing you a video, okay? Is it showing you, do you guys see YouTube or you guys still see the green screen? Do you guys see the green screen or the video?
Green screen.
Okay.
Green screen.
Okay. So let me.
I'll be honest with you.
All right, here we go. So now this is what I don't miss about virtual. Okay. Share screen. Here we go. All right, this is a skydiver with no parachute. Crazy. Okay, here we go.
Did you know, on July 30th, 2016, skydiver Luke Aikens made history when he jumped from 25,000 feet out of an airplane without a parachute into a net on the ground, which set a new world record.
All right, we're just less than 3 weeks out, getting ready for Heaven Sent. We're in the final push of the training. There's a lot of focus from the film crews and the production guys on all the fitness and stuff like that, which is great, makes me feel better. But none of that stuff is what's going to keep me alive on the day. What's going to keep me alive is the jumping, this repetitive practice, practice, practice. If I miss this target, it doesn't matter how good a shape you're in or any of this other stuff that happens. So hitting the target is the most important thing. Accuracy, accuracy, accuracy. Fighting the wind, countering the wind, all that stuff. The next thing is that rollover. I need to roll over about 200 feet. I'm going to be going about 120 miles an hour, and roughly 1 second before I impact, I want to flip to my back and land real nice. It's different than a stunt roll. I have to fly my body around.
Now, apparently, this was a big story at the time. It was even aired live on TV with the name of the show called Heaven Sent. But personally, I've never heard of it before. I just happened to come across his YouTube channel with videos of the jump. But before I show you the jump, let's quickly talk about who Luke Aikens is and how he prepared for the jump. Luke, who was 42 at the time of the jump, is a third-generation skydiver who has been skydiving since the age of 16 and has deployed a parachute more than 18,000 times over the course of his skydiving and base jumping career. Luke Aikens is also a safety and training advisor for the United States Parachute Association, where he provides advanced skydiving training to elite military special forces. So I think it's safe to say he is more than qualified to know the risks associated with such a jump. Luke spent 2 years preparing for this jump, 1.5 years of planning, and 6 months of straight training. And Luke told me they never once jumped from a plane into the net until the day they did this one and only jump. Now, just to be clear, when Luke jumped from the plane, all he had was a GPS, a communication device, and an oxygen tank. What he didn't have was a parachute, a wingsuit, or anything else that might help him stop or slow his descent. After jumping out of the Cessna airplane at 25,000 feet, Luke quickly reached a terminal velocity of 120 miles per hour. Because Luke jumped from 25,000 feet, he had to wear an oxygen mask for the first 10,000 feet of the descent. After reaching about 15,000 feet, he passed off the mask and tank to a member of his support team who was skydiving next to him. Using his GPS and only the air currents around him, he lined up his fall to the center of a specialized 100 by 100 foot net, which was designed to stop Luke's fall as softly as if you were standing on a trampoline and merely dropped onto your back. The net, dubbed the fly trap, was suspended between the tops of 4 200-foot cranes. The netting itself is constructed from Spectra, which is a high-density polyethylene cord that is twice as strong as steel. When Luke reached about 200 feet above the net, or a little more than a second away from impact, he flipped onto his back and tucked his chin. Once Luke hit the net, 4 compressed air cylinders, which are connected to the netting via ropes and pulleys, slowed him down in the same way that you might catch an egg in your hand, by decelerating it gently over a distance. The total time from jumping from the plane to hitting the net took about 2 minutes. But when you were falling from 25,000 feet into a small net you can't even see from 25,000 feet, I bet it felt like a lifetime. Luke Aikens set a new world record performing this jump, and I bet you that's one world record that won't be beaten anytime soon.
Okay. So let me go back. Stop share. And I'm sorry that's choppy, but that's crazy. Like, just to think about the fact that he jumped out of a plane with no parachute. I'm not doing that. I'm just telling you. All right. So let me get back to the PowerPoint here. All right. Here we go. Click. Click. There we go. All right. So when one of the things we'll come back and connect the whole thing with the skydiver, but when we're talking about momentum, has anybody ever heard that word used before?
Yes.
Like, what do you think it has to do with? Like, what does that mean? Like if I say, what if I said I was building up momentum? What does that sound like I'm doing?
Like power.
Power. Okay. So it could be power. And then, so a lot of times we associate momentum with, a lot of people are associated with sports. Okay. So let me see. Sorry, guys. I am trying to juggle. That could be, okay, you can say courage. Yeah. So but it's the fact that you are building up to it. Okay. So whether it's building up to courage or building up to power, there's a gradual increase in something. Now, let me ask, so the question here says, what would you rather choose to duel? Which just means like, which would you be rather hit by? Would you rather be hit by this big football player or this baseball? Okay. So let's talk about what momentum actually means in terms of science. Okay. So what is momentum? So we're about to start our notes. Okay. So if you're on your notes, it says, what is momentum? And the definition is, it's the measure of how difficult it is to stop a moving object. Okay. How difficult it is to stop a moving object. So if you're on your notes, you should have a blank for the word stop.
I just keep bringing up a box.
Say again?
Like when I try to click on the space, it just brings up a box and it's like nowhere near the
Oh, just type in that box, and then if you want to, you can slide the box around. I think, see if that will work. Yep. And if you're struggling, remember you can just write down the blanks, and then the PDF is also on Schoology. So it's totally up to you. And I'll make sure I had the Google form, but it was acting weird today. I don't know why. So I'll try to do that. Okay. All right. So just to show you guys again, you can, if you're not in the OneNote, you can also do it you can just write it down on your notebook for today. Okay. And I'll work out any kinks. All right. So if we are saying momentum, we say it's, if something has momentum, okay, like if we say non-sciencey, like Aurelia said, maybe courage, okay, if I have built up the courage to do something, then it's going to take some effort to stop me, okay? If this big football player, if a linebacker is running towards you, it is going to take some energy to stop him. If a truck is, or even a bicycle, right? Or maybe like you're on a scooter, and if you're going down a hill, it's going to take some effort to stop it. So momentum is basically like, if you have an object, a person or a thing, and it's moving, then momentum is like how difficult it is to stop it. So, it would be easier to stop something that wasn't going. Would it be easier to stop something that was going fast or slow? Which would be easier to stop? Something going fast or something going slow?
Slow.
Yeah, something going slow, okay? So the thing that's going fast has more momentum, okay? Would it be easier to stop, let's say somebody was running towards you. Would it be easier to stop a 2-year-old or like an 18-year-old? Which one do you think would be easier to stop?
Probably the 18-year-old.
I'd be, the 18-year-old would be easier or harder to stop if they were running towards you?
Harder.
Yeah, they're harder, exactly. The 2-year-old will be easier to stop. So let's think about those two different scenarios, okay? So one of them, I said something moving slower, something moving fast. And then I said the 2-year-old and the 18-year-old. What's really the big difference between the 2-year-old and the 18-year-old? Like, why would it be easier to stop a 2-year-old?
Weight.
Weight, exactly, weight or mass, okay? So because that 2-year-old has less mass, it's easier to stop it. And that's exactly what momentum has to do with. Momentum has to do with how fast you're moving and what mass you have, okay? So let's go to this next one. Okay, momentum is basically mass and motion, okay? It's mass and motion. And it has to do with mass and velocity. It has to do with mass and velocity. All right. So I'm just following along on my notes with you. So you should have written the measure of how difficult it is to stop a moving object, mass in motion, and then momentum depends on mass and velocity. Okay, that's what I got so far.
Excuse me. It's
Yeah.
not letting me type. It's not letting me type in the box.
It's not letting you type in the box. Okay, let's how about for today, just write. Can you have some notebook paper nearby?
Yes, ma'am.
Okay, just write on there, and then I'll figure out, make sure that everyone can write on it next time.
All right.
Okay. And I'll also make sure I do the Google Doc. Oops. All right. So, measure of how difficult it is to stop a moving object is mass and motion, basically, and it has to do with mass and velocity. Okay. And I'll put a copy of what we do today just in case some of us get behind because we're trying to work the OneNote and stuff. All right. Oops, wrong way. Wrong way. Sorry. All right. What is momentum? So, all right, here we go. It's going to be a weird letter, I know. Okay, but remember we already have M for mass, okay, and that's measured in kilograms. And then we have V for velocity, okay, and that's measured in meters per second. Now, I know this sounds weird, but for momentum, the letter we're going to use is P. But we've already used M for mass, okay? Now I can't tell you, it's probably has something to do with the Latin word for momentum if I had to guess, but I can't tell you exactly why we're using the letter P, but that is the letter we are going to use, okay? So P is going to be momentum, all right? So when we look at this, the formula for momentum is going to be mass times velocity. Okay, it's going to be mass times velocity, or P is equal to M times V. Okay, P is equal to M times V. I'm going to fill in my notes too so that I can post them for you guys. Stop mass in motion. Mass and velocity. All right, so on that table, you should be able to write the variable used for momentum is P, for mass is M, for velocity is V. And then those units, meters per second and kilogram. And then this momentum one, okay, because we're multiplying those, it's the kg from mass times the M from velocity, and then this is still divided by S, so this divided by S is there, okay? So it's basically K on the top, it would be kgm, and then divided by S. Excuse me. All right, I have filled in my notes. Okay, hopefully you got yours filled in. All right, so let's keep going. All right, so here is our triangle, our handy dandy triangle, okay? If we want to find momentum, which is P, we're gonna multiply these, okay? If we're not looking for P, we should be dividing, and P will always be on top, okay? So if I'm looking for mass, it's gonna be momentum divided by velocity. And if I'm looking for velocity, it's gonna be momentum divided by mass, okay? So remember, if you wanna draw if you're writing on your notebook paper, you can draw your triangle, okay? Or you can just copy down these three formulas, okay? And the homework that we're gonna work on, we may not even start today. We may just work on it on Thursday. It's just gonna be practice problems with these, okay? Now remember, sometimes I will give you shortcuts when we do our quizzes where you could get rid of one or two answers. What's one of the first things you should look at when you're looking at your answer to see if it even makes sense? Anybody remember? Okay, it's the unit. So remember, like for instance, if I give you a question and I say, what is the momentum? Okay. And then if you see answer choices and one of them is in kg and one's in ms, those can't be right because I asked you for momentum, and momentum is kgms. Okay, so always check your units. All right, let's go to the next part of the notes. Look, we're already on the second page, or third page technically. All right, so here's the relationship between P, M, and V, okay? Mass and momentum are directly proportional, okay? So that's just a fancy way of saying if you make one bigger, the other one gets bigger. If you make one smaller, the other one gets smaller, okay? Let's see what we got. Okay. All right, let me pause this for a second because I don't want you guys to get frustrated with this one note. So I'm going to pause my recording for a second so I can look at this one note. All right. So the relationship between PM and V, PM and V. Okay, and we'll do this and then we'll be done for the day probably. All right, relationship between PM and V. All right, remember P is momentum. Sounds weird. M is mass, V is velocity. We should know these two because we've already kind of talked about these in the past. All right, so directly proportional, that's just a fancy way of saying if one goes up, the other goes up. If one goes down, the other one goes down. Indirectly proportional, which we don't have on here, which would just mean they're opposites. It would mean if one goes up, the other one goes down. So if I increase in mass, I will increase in momentum, okay? So if I have two people and they're running the same speed, but one of them is a 300-pound linebacker, okay, and the other one is a, I don't know, 175 wide receiver, the linebacker is going to have more momentum. He is going to be harder for me to stop because he's bigger than the other guy, okay? Or if I have, you know, two people running towards me and, or if I have, okay, a sports car, okay, and a semi truck, and they're going at the same speed, okay, it's going to be harder for me to stop the semi truck because the semi truck is bigger, right? So that's kind of what I'm trying to show you down here in this visual. If I have a bicycle, a bike or a bicycle, and a car, this car is going to have greater momentum because his mass is bigger than this bicycle, okay? So they both have momentum, But because the mass of the car is bigger, it's going to make this momentum bigger. Okay. So that's one thing that affects momentum is mass. The other thing is velocity. Okay. So we can take, let's go back to the football players or the trucks. Okay. If I have two semi trucks and they're the same mass, but one is going 65 miles per hour and the other one's going 85 miles per hour, the one that's going 85 miles per hour is going to have a greater momentum. It's going to be harder for me to stop it. Okay. So if we do the semis, or if we do two people that weigh the same thing. Okay. So we have two people, they're both running towards, let's say they're running towards a fence. Okay. And they're supposed to stop when they get to the fence. It is going to be harder for the one that's running faster to stop, even if they weigh the same amount. Let's say they both weigh 150, okay? Even though they both weigh 150, the one that's going faster is going to be harder to stop, okay? So that's what I'm saying here for the slow bike versus the fast bike. This one, the speed is not as big, so the momentum is not as big. Over here, the speed is bigger, so the momentum is bigger. Okay. If I increase velocity, I will increase momentum, or if I increase mass, I will increase momentum. Does anyone have questions about that? Okay. Okay, let's do one or two practice problems and then we'll be done, okay? All right, here's a calculation. All right, Corey drives her car, which weighs 1,500 kilograms, down Whitlock Avenue at 11 meters per second. And it says calculate her momentum, okay? So I'm gonna share my screen for a second. Let's see. Give me 1 second here. All right, I'm going to share my screen. All right, let's see if you guys see what I see. What are you guys seeing right now? Somebody unmute and tell me.
A green screen with a problem up there.
Yeah.
Oh, okay, maybe, oh, this was that. Do you want to continue? Yes, okay, sorry. Now let's try. Here we go. All right, so this is the same problem. So these are straight from the, so I'm on the notes right now, okay? So I was filling in notes here, okay? All right, so if we do these two practice problems, let's do like maybe these three. All right, so variable bank. We have a couple of different variables. We have P, M, and V, all right? Corey drives her car, 1,500 kilogram car, down Whitlock Avenue at 11 meters per second. And it says calculate her momentum. So the first thing is, let me ask you this. Which one of these are we looking for? Are we looking for P, M, or V?
P.
Looking for V? Wait, what'd you say?
P.
P. P as in Peter, right?
Yeah.
Okay. We are looking for P. Very nice. All right. So we have two numbers left. We have 1,500 kilograms and we have 11 meters per second. Jordan, where do you want to put the 1,500 kilograms? How much the car weighs? So you want to put that for M or for V?
For M.
For M, very nice. All right, so I'm gonna put 1,500 kilograms here. All right, and that must mean that V is 11 meters per second. All right, well, we're using the same formula the whole time. P equals M times V. So now I'm just gonna, when we say plug and chug, it just means plug in the numbers where you have letters. So I don't have a P, so I'm gonna write P still. I do have an M, okay, that's 1,500. And I do have a V, which is 11. So if I put that in my calculator, 1,500 times, oh, thank you, Adela. That is correct. P is equal to 16500. All right, so here's the weird thing. You gotta remember that long thing, okay? So it is KG, if you want, you can put a little dot right there, M over S. Very nice. Okay. All right, let's do this next one. All right, we know this is still gonna be P equals M times V. We still need P is equal to, M is equal to, V is equal to. This one says, what is the momentum of a 1,000 kilogram Civic? So that's a Honda Civic traveling at 30 meters per second. Kaylee, what do you think we're looking for? Are we looking for P as in Peter, M, or V as in Victor? It's kind of hard for me to hear the P versus V, so I just said that.
P.
We are looking for P, so I'm gonna put question mark right here. Question mark, don't know what that is. All right, and then Bless, where do you want to put the 1,000 kilograms, M or V?
B, I think.
You said, did you say, I didn't hear you, the mass right here, this 1,000 kilograms, where do you want to put that? Do you want to put that for M for mass or V for velocity?
M.
Yes, very nice, M. So we're gonna put 1,000 kilograms right there. And that must mean 30 meters per second goes there. All right, so now we're just gonna plug in what we got. We don't know what P is. P is equal to, all right, and then we're gonna plug in for M. We're gonna plug in the 1,000 times 30. Very nice, Adela. All right, and then P is equal to, when you put that in your calculator, 30,000. And again, it's that KGM over S. All right, one more and then we'll be done. Okay, I want to do one where we don't solve for P. Okay, where we don't solve for P. All right, I'm going to scroll up just a little bit. All right. This one says, what is the velocity of a 100,000 kilogram locomotive? Locomotive is just a train with a momentum of, oh my goodness, 3 million kilogram meters per second. Okay. All right, Gloria, are you there? No Glory. Reagan, are you there? Can somebody tell me what we are looking for? What are we looking for on this one?
Velocity.
Velocity.
Yes, very nice. We're looking for velocity. So I'm going to put my question marks down there by the V. All right. And then we had 100,000 kilograms. 100,000 kilograms. And then we have the 3 million kilograms meters per second. Okay. My nephew's checking on me, but he obviously forgot that I am teaching right now. So, all right. So the 100,000 kilograms, Lydia, where do you want to put that? P as in Peter or M? Yes, M for mass, very nice. All right, so oops, forgot to change my pen back. All right, 100,000. Oof, that's a big number. And that must mean that P is this 3 million. 1, how many zeros? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. KGMS. Okay. All right, same formula. So I'm going to write P equals M times V, or what could I also write? What if I'm solving for V? How do I get V is equal to what? Anybody remember from your notes? P is equal to, we got to divide. Which one goes on top?
Mass?
No, not quite. It will always go on top. So mass is going to go on the bottom. Good guess though.
P.
All right. Yes, P is going to go on top and mass is going to go on bottom. Okay. So anytime you're not doing P equals MV, P will always be on top. Okay. So if we were looking for mass, P will still be on top. So just keep that in mind. Okay. P will be on top. All right. So for this one, we don't know what V is. So V is equal to, P is the 3, 1, 2, 3, 4, 5, 6, and then divided by 1, 2, 1, 2, 3. V is equal to, Dayla is on it today. Very nice. Let me, 2, 3. Very nice. 30. Now this is velocity. So what unit should I use for velocity? Anybody remember? Is either kg ms or kgm over s.
MS.
Very nice. M over s. Very good. Okay. All right. So guys, this is what I'm going to do. I'm going to work on making sure I get everything right. I do have a quiz for you guys, but I'm just going to wait and we can just kind of do a couple more practice problems on Thursday. And then we can just do the quiz in class, kind of like what we normally do. Okay. Any questions? I'm going to stop recording, but I'm going to leave this up on the screen just in case you're still writing.